Hey guys, Camille here. The elephant's toothpaste demonstration is what helped me win Miss America, and today I'm going to show you how you can do it at home. So you're probably really familiar with hydrogen peroxide. Maybe you've used it when you got a cut or a scrape and you used it as an antiseptic to clean out that wound. Now, when you do that, you normally see bubbles form. The chemical formula for hydrogen peroxide is H2O2, and when it breaks down, it creates water and oxygen gas, which are H2O and O2. So when you pour hydrogen peroxide on a cut or a scrape, you're seeing bubbles form because the hydrogen peroxide is breaking down. Now, hydrogen peroxide breaks down frequently. It breaks down with light, which is why it's frequently packaged in a dark brown bottle. But there are other things that can break down hydrogen peroxide. Catalysts are chemicals that speed up reactions. And there are biological catalysts and chemical catalysts. So when you pour hydrogen peroxide on a cut or a scrape, what is really happening is that hydrogen peroxide is reacting with a biological catalyst. It's an enzyme in our body called CATALASE. And CATALASE's job is to break down hydrogen peroxide. So those bubbles that you see form are coming from that catalase, breaking that hydrogen peroxide down into water and oxygen gas. Catalase is an enzyme that is present in pretty much all living things that are exposed to oxygen. It's in us, but it's also in yeast. The basis of the elephant's toothpaste demonstration is the catalytic decomposition of hydrogen peroxide. And so to break down that hydrogen peroxide, we are going to use the power of yeast. Because of the catalase, when you mix yeast with hydrogen peroxide, the hydrogen peroxide will rapidly break down, forming water and oxygen gas and a little bit of heat. But if we really want to see the oxygen gas that we form when we break down hydrogen peroxide, we can add dish soap to trap those gases and turn them into bubbles. So when we're done, we are going to see a giant plume of foam that's created by the breakdown of hydrogen peroxide. There are just a few simple materials that you will need to do elephant's toothpaste at home. You need some liquid dish soap, you need hydrogen peroxide from the pharmacy at 3%, you need an empty water bottle, some food coloring, a few measuring cups, a tablespoon, a package of dry yeast, and a pair of safety glasses and gloves. It's also a good idea to get a covered tray to collect any of the foam that falls over the bottle when you do your reaction. So before I get started, I'm just going to do a few things to make sure I'm protected. I'm going to put my hair in a ponytail, and I'm going to put on my safety glasses and gloves because hydrogen peroxide can irritate your skin and eyes, so you want to make sure that you are fully protected. It's really important to note that even though this is fun and it's called elephant's toothpaste, it isn't really toothpaste, and we never want to put any of our materials or chemicals in our mouth. So go gather your materials because we're about to get started. Okay, so I have my empty water bottle here on my tray, and the first thing that I need to do is pour in 1/2 cup of hydrogen peroxide. The next thing you're going to need is a big squirt of dish soap so we can make sure that we catch all of that oxygen that's formed when we break the hydrogen peroxide down. Now swirl around your hydrogen peroxide and your soap to make sure that it's fully mixed. So if you want to make this extra fun, bring out some food coloring. You can either put a few drops and mix it into your solution, or if you want to make it striped like a tube of toothpaste, you can drop a few drops of food coloring down the sides of your bottle and don't mix it. So when the foam comes out, you will see stripes of color. So I'm going to do a stripe of green and a stripe of blue to really get in the spirit of toothpaste. I took a measuring cup and I just added 3 tablespoons of warm water. And to that, I'm going to add 1 tablespoon of yeast and stir it around for about 30 seconds. So now is the moment of truth. I'm going to take my yeast mixture, pour it into my bottle to start the reaction. That is really cool. I don't think my stripes worked very well, but this is such a pretty blue color that I don't mind. So I want you to think about what is happening. So that yeast had an enzyme in it called CATALASE, the same one that we have in our body, and it worked to break down all of the hydrogen peroxide molecules that were in my bottle. So we formed water, which is probably still in my bottle, and we formed oxygen gas, which got trapped in that dish soap and formed all of this foam. I also want you to notice how long this reaction is happening for. Okay, the reaction is still happening, and now we're seeing some really cool stripes come out. So what do you think controls how long the reaction happens? What do you think controls the rate of how quickly the reaction happens? So this is a wonderful example of catalytic decomposition. In this case, we are using a biological catalyst. You can also use a chemical catalyst, like potassium iodide, although that's not something you should try at home. Now, if you want to dig a little deeper into the elephant's toothpaste demonstration, here are a few variations that you can try. What if you tried to do this without dish soap? How do you think it would be different? In this demonstration, we used an empty water bottle. How do you think the shape of the vessel affects the way that the reaction progresses? Explore this activity with some different types of containers around your home. Try some with wide necks, some with smaller necks, and different shapes, and see how it changes what the reaction looks like. And why do you think that the shape of the vessel changes the way that the reaction progresses? Here's a quick rundown of the science of what happened in our demonstration. The minute that yeast comes in contact with the hydrogen peroxide, it starts breaking down into water and oxygen gas. Oxygen is a gas, and it really wants to escape out of the liquid. But we added dish soap, and so that traps the gas and forms it into bubbles, which cause this beautiful foam. So the reaction will continue as long as there is still hydrogen peroxide and yeast. But once one of those things runs out, the reaction will stop. When you are done observing your beautiful elephant's toothpaste, you can pour out your bottle, wipe up your phone, and wash it down the sink with lots of water, and make sure to put away all of your materials. Thank you so much for watching, and I hope that you try elephant's toothpaste at home. And if you do, snap a photo and post it to social media. Tag me at Camille Schreier on Facebook, Twitter, and Instagram. And remember that science really is all around us.